In this video, I'm going to show you the smartest and fastest way of solving this Olympiad exam equation that has to do with a polynomial question. To solve this, let's go straight to solving it. To solve this equation, I'm going to make x to the power of 3 minus x, and this will be minus 24, and this will be equal to 0. And this is a polynomial equation. Since we subtracted 24 from both sides, the right hand side will be equal to 0. So what do we do from here? From this point, I want you to look at an analogy. If we have negative 27 plus 3, this will be equal to a negative 24, right? Good. So that means minus 27, negative 27 plus 3 can replace minus 24. So let's try that and imbibe that into the equation. So this will give us x to the power of 3 minus x minus 27 plus 3, and this will be equal to 0. Definitely, we can solve this other polynomial equation by looking for a value of x, in which once we substitute it into this expression, the polynomial expression, we are going to have 0. And once we have 0, that means that value of x is a factor. So we can substitute that value of x, divide it with the main polynomial equation to get a quadratic equation. And once we get that quadratic equation, we can now solve that quadratic equation to get the other two factors. Now, this is the fastest way to solve this. Now, having done this, we can say x to the power of 3 minus 27 minus x plus 3 will be equal to 0. So let's simplify this further. To simplify this further, we're going to have x to the power of 3. Remember that 3 to the power of 3 is equal to 27. So we'll replace that. That will give us 3 to the power of 3 minus x plus 3, and this will be equal to 0. Fine. Now recall a quadratic, an algebraic formula. In that algebraic formula, if we have a to the power of 3 minus b to the power of 3, this will be equal to a minus b, right? And this will be equal to a squared plus ab plus b squared. This is an algebraic formula. So if we use that algebraic formula, if we substitute that algebraic formula, we are going to have that expression to now give us our a is equal to x, remember, and our b is equal to 3. So we'll have that, will now give us x minus 3, that's the first expression, right? And then we'll have x squared, right, plus 3x plus 3 squared, right? This will now give us minus 1 multiplied by x minus 3, and this will be equal to 0, right? So if you simplify this, you find out that you're going to have this expression. Cool. Now let's simplify this further. With this expression, we now have two common values of x minus 3 and x minus 3. So it is common. So we're going to bring out x minus 3, which is common. And if we bring that out, if this whole value divide x minus 3, we're going to have x squared plus 3x, right, plus 9. And that will give us, if minus 1, this whole value divide x minus 3, we're going to have a negative 1, and this whole thing will be equal to 0. Fine. So we have two expressions now. What are the expressions? We have x minus 3 to be equal to 0, and then we'll have x squared plus 3x plus 9 minus 1, and that will be equal to 0. So if we simplify that expression, the first one, we're going to have x minus 3 equal to 0. So let's add 3 to both sides. Our x will be equal to 3. So this is the first solution to that exponential equation. Now let's look at the second solution. We have x squared plus 3x plus 9 minus 1 is going to give us plus 8, and this is equal to 0. So we're going to solve this expression using the quadratic formula. From the quadratic formula, our x is equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a. And from our expression, a is equal to 1, b is equal to 3, and our c is equal to 8. So if we substitute that into the value, the quadratic expression, we are going to have our value of x to be equal to the negative 3 plus or minus the square root of 3 squared minus 4 multiplied by 1 multiplied by 8, right? And this will be divided by 2 times 1 is going to give us 2. So our x will be equal to negative 3 plus or minus square root of 9 minus 4 times 8 is going to give us 32 divided by 2. Now let's simplify that expression. The expression is going to give us x to be equal to negative 3 plus or minus the square root of negative 23 divided by 2, right? So our x will be equal to a negative 3 plus or minus square root of 23 multiplied by the square root of negative 1, right? And this will be divided by 2. Good. So now we are going to simplify further. Remember, from complex number, a negative 1 can be equal to the imaginary. So we are going to have x to be equal to negative 3 plus or minus square root of 23 imaginary divided by 2, right? So our x is going to give us two values, negative 3 plus square root of 23 imaginary divided by 2, and is going to give us minus 3 minus root 23 imaginary divided by 2. Now the whole expression, the solution to that equation, the whole expression, the values of x for that polynomial equation is x equal to 3 and our x equal to negative 3 plus square root of 23 imaginary divided by 2, and our x is equal to negative 3 minus square root of 23 imaginary divided by 2. So these are the three solutions to the quadratic, the polynomial equation given to us right there, up there. Now what we're going to do is to confirm if our solution is right. So we are going to substitute the only real solution. The other two solutions are imaginary solution. We are going to substitute the only real solution into the expression. The only real solution, x is equal to 3. So let's substitute it into x to the power of 3 minus x. Will it give us 24? That's a big question. Now let's try it. To the power of 3 is 3 to the power of 3 minus 3 equal to 3 to the power of 3 is 27, right? Minus 3, 27 minus 3 is equal to 24. So we see 24 on the left hand side is equal to 24 on the right hand side. So what does that tell us? That tells us that the value of x equal to 3, which is the only real solution, satisfy the exponential equation we have up there. So I know you did enjoy watching this video. Don't forget to give it a thumbs up, share it with friends and colleagues, and remember to also subscribe to my channel for more simplified mathematics solutions. Thanks so much for watching, and bye bye for now.